Okay, let's look at some examples from 1.8, from the 1.8 homework. The first one we'll start with is number 3, where this question is asking us to find the second derivative, right? We've got 2 apostrophes up there, so this is the second derivative. Well, what does that mean? That means I'm going to take the derivative and then take the derivative again. I'm going to take the derivative twice. That means first step is to find that first derivative. First thing I have to do is find the first derivative here. Well, what do you notice about this function? We have a function inside of another function, right? I have an inside function here, and therefore I'm going to need to use chain rule. Okay? Hopefully at this point you guys are a little bit more comfortable with the chain rule, so I'm going to go through it a little bit faster. Right? I'm going to take the derivative of the outside function, bring that 4 down, keep the inside function the same, and then subtract 1 from the exponent. So that's the derivative of the outside function, and then I need to multiply it by the derivative of the inside function, which gives me 4x minus 4. Right? Derivative of 2x squared is 4x to the first, which of course is just 4x, and then minus 4. Okay, so there's my first derivative. Now what? Now I'm going to take the derivative of this derivative that I just came up with. Well, what does this derivative require? This requires product rule. You've got 2 different functions that are being multiplied together, and so now I need to use the product rule to find this derivative. Okay, so let's split it up. Let's classify my 2 different functions. So h of x, my first function, I'm going to go ahead and lump in that constant multiple there as part of this function. So I get this 4 times 2x squared minus 4x plus 5 raised to the 3rd power. That's my first function. And then my second function is that 4x minus 4. Okay? In order to complete product rule, I need the derivatives of both of these. We'll start with the easy one. What's the derivative of g? It's just the slope, right? It's a linear function, so it's just the slope. So 4. Derivative of h. Well, this requires this requires chain rule again, because I have that same situation where I have 2x squared minus 4x plus 5 inside a power function. So when I use chain rule, I'm left with 4 times 3 is 12 times that inside function, and then I decrease the exponent by 1 again, so squared, and then I multiply by the derivative of the inside function, which we already know what that is. It's just 4x minus 4 again. Okay, so now we have both of my functions and the derivatives of each of them, and now I can put it together by cross multiplying. So h times g prime, I get 4 times 2x squared minus 4x plus 5 raised to the 3rd power times 4. Plus, and then h prime times g, I get 12 times 2x squared minus 4x plus 5 raised to the 2nd power times 4x minus 4 times 4x minus 4. Why do I have 2 of them? One of them comes from the derivative of h, and the other one comes from g. So that's why they end up with 2 of those. Once again, this is where I now have completed the second derivative. I have taken the derivative of the first derivative, so this is my second derivative. At this point, you could simplify, or you could go ahead and just plug this in for your answer, and it'll give you the correct answer. But simplifying is always a good thing to practice, so I'm going to go ahead and simplify this. And there's your second derivative. Once again, how did we get it? We took the derivative of the function, and then took the derivative of that derivative, which ended up requiring product rule, which is why it ended up being longer. Okay, the next problem we're going to look at is number 9 from the homework. And the reason why we're looking at this one is this one's related to physics. So this is where we're going to be talking about acceleration, which is how the second order derivative can be very helpful. So let's look at this problem. When an object is dropped on a certain Earth-like planet, the distance it falls in t seconds, assuming that air resistance is negligible, is given by s of t equals 19t squared. Why does this have to be an Earth-like planet? Because Pearson likes to change numbers around, but Earth always has the same gravity constant. And so that's why Pearson's like, okay, this is just Earth-like because they're changing the gravity constant here. Okay, so S of t is in feet. Suppose that a medic's reflex hammer is dropped from a hovering helicopter. Apparently they have helicopters on this Earth-like planet. We're gonna find three different things. First, how far does the hammer fall in 2 seconds? B, how fast the hammer is traveling 2 seconds after being dropped? And C, what's the hammer's acceleration after it has been falling for 2 seconds? Part A. Part A is just asking, how far has the hammer fallen in 2 seconds? Well, what does that sound like it's asking for? It's asking for a distance. It's asking for a position. So therefore, for this problem, I'm really just concerned about the position of the object, and all I need is my position function. What is it asking? It's asking for the position after 2 seconds, or just S of 2. Finding that is straightforward enough. You just plug 2 in for t. 2 squared is 4. 19 times 4 is 76. And that's it. That's all there is to part A. Part B. Part B is asking how fast is the hammer traveling 2 seconds after being dropped. Well, what does that sound like? That sounds like velocity. So I need to know about my velocity for this part of the question. Well, what's velocity? Velocity is the derivative of your position. So I need to find the derivative of my position function, which is just 38t. How fast is it traveling after 2 seconds, or traveling 2 seconds after being dropped? All I need to do is just plug in 2. 38 times 2 is, look at that, 76 again. Now, these numbers are the same, but remember the units are different on this. This represents the hammer traveling 76 feet. This represents the hammer traveling at a speed of 57 or 76 feet per second. Last, what's the acceleration of the hammer after 2 seconds? Well, this one says very clearly what I'm going to need to know. I'm going to need to know the acceleration function for this hammer. Acceleration is just your derivative of your velocity. So what's the derivative of my velocity function? Just 38. That's it. Notice it doesn't actually depend on t. So what's my acceleration after 2 seconds? Well, it's the same. The acceleration is constant. That's why with Earth, that gravity constant, we call it a gravity constant because your acceleration is always constant. And so the same is true for this Earth-like planet. So my acceleration after 2 seconds is just 38. 38 what? 38 feet per second squared. That's my unit for acceleration. And that's all there is to number 9. The trickiest part of it is just making sure you understand what it's asking for. Okay, good luck with the rest of the homework, and we'll see you in our Chapter 2 videos.